So let's go to the first one. What is 1/2 of 2 to the power of 22? This is a trick question. I think we've done something like this at some other time, so I'm not going to spend any time on it. All you have to do is to just divide this by 2, use the second law of indices, and you are there. So this is 2 to the power of 22. 1/2 means you're dividing by 2. The second law of indices says that this is, you subtract the indices when you're dividing, and that's the answer. In these questions here, I am not putting down choices A, B, C, D, E, right? So if you want, you can just write down the answers and you can check them against what you have already, what you did, so that you can figure out how many marks you're going to get. Okay, so let's get on to the next question. Question 2. Sorry, I'm just having some problems getting to my page. Okay. All right, so the second question is the difference between the squares of two numbers is 80. The sum of the two numbers is 16. What is the positive difference between the two numbers? Okay, now this is a good example of where you use some symbols. You don't know what the numbers are, and so you let them be x and y. Let x and y be the numbers. And the difference, we are speaking about the difference. So let's just say that x is greater than y. So that when we subtract, we're subtracting the smaller one from the larger one. So x squared minus y squared. The difference between the squares is 80. The smaller square minus, take it away from the larger square. And they say that the sum is 16. Okay, so yes, we've seen this many times. The difference of two squares is such an important concept. X minus y into x plus y. Very, very fundamental in maths. So you can factorize the difference of two squares, and you know x plus y, so that is 16. So x minus y times 16 is 80. This is not degrees. X minus y times 16 is 80. So x minus y would be 80 divided by 16. It just gives you 5. And that is what they were looking for, the positive difference between the numbers. X is greater than y, so x minus y is positive. And that is what we've got here. So the answer is 5, the positive difference between x and y. I should have said that up front. What are we looking for? We're looking for the positive difference between the two numbers. Once you name the numbers, x is greater than y, we are looking for x minus y. Always write down, know what your goal is in a mathematics problem. So the goal is to calculate x minus y, and this process here leads to that solution. Okay, so let's get to the third question. Question here is, what is the value of a if 3 root 3 plus 2 root 11 minus all this is equal to something else? So let's just simplify this thing. I got a bracket here, so let's just remove the bracket. So you got 3 root 3 plus 2 root 11. When you remove the brackets, it becomes minus 3 root 11. And the minus there becomes plus. And that is equal to 4 root 3 plus a. Now this is a number here, and the question is to find a. So we need to know what is this thing. Okay, well, let's just bring all the root 3's together. 3 root 3 plus root 3 root 3 is 4 root 3. All right? And this 4 root 3 will cancel the 4 root 3 on this side. If you want, you can bring the 4 root 3 to the other side, and 4 root 3 minus 4 root 3 is 0. So the only thing you're left with these two things, and you have 2 root 11 minus 3 root 11 is minus 1 root 11, or just minus root 11. And that is a root 11. And therefore, a is equal to minus 1. You simply divide minus 1 root 11 divided by root 11. Root 11 cancels off, and you get negative 1. I just want to show you something here. Okay, I can use the same page. Now here's something which is often asked in Olympiads, but very few people explain what's going on. Suppose I tell you that 3 plus 4 root 11 equals, say, a minus 3 or a minus 1 or whatever, plus b plus 1 root 11. And we are given that a and b are rational numbers. Rational numbers are numbers which can be written as a fraction, as an integer over an integer. And the question is, calculate a and b. Now, a lot of people who do this say, well, this is easy. Root 3 equals a minus 1. So I got a root 11 here, I got a root 11 here. So therefore, root 3 is equal to, 3 is equal to a minus 1. And a is equal to 4. And the same thing they do with 4 root 11, b plus 1 root 11. And they calculate b, and they say b is 3 because 3 plus 1 is 4. And they get full marks for this. Okay, I say excellent. But there's something wrong with this, because if I say 2x plus y equals 3x minus y, does this mean that 2 is equal to 3? Does it mean that 1 is equal to minus 1? Just because you got the same symbols here, does it mean that those coefficients are the same? So although the answer is correct, the purpose in this little digression is to tell you why the answer is correct. See? Why can you make a minus 1 equal to 3 and b plus 1 equal to 4? That is correct, but why? It leads to the correct answer, but what is the reason for that? And the answer is as follows. You see, I can bring all the root 11s to one side and the a's to the one side. You get 4 minus a. Bring these numbers to that side. And here you get b plus 1 minus 4 root 11. That's the only thing you can do. You can say, bring this to this side, bring that to that side, and you're here now. Now, how do you know that b equals 3 and a equals 4? You don't know that. What you do know is that root 11 is equal to 4 minus a over b minus 3. But do you know that? Moda, I can see your name here. Is this true? 4 minus a equals b minus 3 times root 11. Therefore, you can make root 11 the subject of the formula. 4 minus a over b minus 3. What's your comment on that, Moda? Moda. All right, she's not answering. Is anybody else wants to make a comment on this? Are we allowed to do this? No comment? Nobody? Not a single one to save the souls of all of you.
I would assume yes, Prof.
You'll say yes, all right. At least you gave an answer. Okay, so root 11 is equal to this. Any other comments? All right, so the general feeling is that, yeah, it's true. Be very, very careful. Look here. Zero times x I'm sorry, 15 times 0 is equal to 0. Is equal to 14 times 0. Both of them are equal to 0. Therefore, 15 equals 14. This is false. That is why they say you're not allowed to divide by 0. I'm dividing by b minus 3 here. I'm not allowed to do that. You have to precede that with if b minus 3 is not equal to 0, then you get that. Only when it's not equal to 0 can you divide. You're not allowed to divide by 0. Okay? So this is true, but you must state that condition. You guys are senior students now. Stuart, you agree with that? You have to say that this is not...
Yes, Prof. I would agree that b minus 3 cannot equal 0.
Yeah. All right. So, but now a is rational, right? It's a rational number.
Yes,
Fraction.
yes.
B is also a fraction. So if I put a fraction here and fraction there and so on, now simplified, wouldn't I get another fraction?
Yes.
So it means that root 11 is a fraction. It's a rational number. That is false. The square root of 2, the square root of 3, the square root of 5, all these things which are not square roots, they're all irrational numbers. Important to know that. They're not rational. You cannot write it as an integer of an integer. It's impossible. Some other time maybe I'll prove it for you. Can remind me why all these things are irrational. But for the time being, know that the square root of 11 is irrational. So this is a contradiction. Because we said that A and B were rational, so this is a contradiction. Why is it a contradiction? The contradiction is because we made this assumption. This led to a contradiction. So this is false. Right? This assumption is false. And therefore B equals 3. You see? So we can say that B is equal to 3, as we said earlier on, and substitute that and you will see that A is equal to 4 or whatever. That is why B equals 3. You can put these things, you can equate them simply because Root 11 is an irrational number. That's the crux of the story. Are you all happy with that? Why is there such a deafening silence? You guys are with me for 5 weeks now. You're so scared of me. Huh? Are you happy with that?
Most definitely, Prof.
All right.
Yes, Prof.
Okay, good. At least I got 2 people, the same 2. The other people belong to the silent majority. Okay, let me just see who's in the class here. None of you have put your names on. There are 34 people in the class. Come on, let me see your names. Okay, we got some people in the chats column. Kabir. Okay, Kabir says it does not make sense since an irrational number cannot be expressed. Okay, Kabir made that point. That's very good. Okay, so we've got some comments here. Catherine and Kabir made some interesting and wise comments. Thank you for that. Okay, so let's just go on to the next problem. Okay, so we are doing I think this is the one we are doing now, right? The next one, number 4, find the numerical value of this. All right, so once again, you see a difference of 2 squares. It's so popular, you know. Whenever you see a difference of 2 squares, don't hesitate. Write it down. A squared minus b squared is a minus b into a plus b, right? So this thing, if I want to simplify it, I'm going to factorize this thing. You're not allowed to use a calculator. Unfortunately, many of these things are written online. I'm not sure if some people are writing this online. So they can cheat. They can use a calculator and they get this answer very quickly, faster than the others, which is very unfair. Let's take this left-hand side here. Right? That's the difference of 2 squares at the top there. 2023 squared minus 2021 squared is that. And now this thing can be calculated easily because this is 2 there when you subtract. And when you add these 2, you get 4,044. 4,044 divided by 2. And I don't multiply, I cancel. These are fractions. Canceling fractions is very powerful. Those people who came to me on Thursday, we spoke a little bit about that. So this first number here is 4,044. Okay, so now let's go and try to work out the second number. Done in exactly the same way because that's again another difference of 2 squares. So this thing here, I'm going to do it mentally. 2023 minus 2021, which is again 2. Oh, it's the same thing. And we saw this was 4,044. No.
Yes, Prof.
That was 2 times. This was 2 times 4,044. No, the 2's cancel. Okay. Yeah, right. So it's the same thing at the top. So this is 4,044 again. But now you're dividing by 4,044, which is very pleasant because you can cancel that. So this part here is equal to 2. So you're subtracting 2 from 4,044. So your answer is 4,042. So this illustrates the power of the difference of 2 squares. We have in our talks come across this many times, and I trust that you benefited from those discussions and applied that knowledge successfully in getting to this answer. Okay, let's just make a quick check. How many of you got the answer 4042? Put your hands up. Reactions? Ray, report to me. Okay. Squire, very good. 12. Oh, good. I should expect more. All right. Seems to me that less than half of the people got this out. There should have been more. Okay. We've discussed this many times, the difference of two squares. Okay, the next one is okay, question 5. Question 5 asks this question: for how many integer values is n over 250 over n a positive integer? So we have to understand the meaning of this. First, always try to interpret exactly what are they saying. So you got 250 over n is a positive integer. Okay, the fact that it's positive means that n is positive. Just note that. And this is an integer. For it to be an integer, n goes exactly into 250. That's the only time it can be an integer. So you want to see which numbers go exactly into 250. And let's start with 1. 1 certainly is a factor of 250. 2 is. The next one, oh, okay. I'd like to write this thing down as 1 and 250. Right, write both of them. The next one is 2 goes exactly into it, and then it's 125. 2 goes into that 125 times. The next factor that you will get to 3 and 4 are out, because 50 is not a multiple of 4, but 5 is certainly in, and the other factor is 50. Now, if you go through now 6, 7, 8, 9, 10, you see you don't come to anything, but you come to 10, it comes to 25, 10 times 25, and then when you go up a little bit more, you see you don't have any others, maybe 15, but even 15 doesn't go into it. So these are the only ones. So the answer, if you want to list them down, the answer is 8. And these are they all must be positive. Now you could have had -1 is also a factor, remember that. Negative integers are also factors. That in that case I have -1 and -250, but they are not allowed because we are told that these are positive integers. All right. Now the other way of doing this is that we have seen this before. You factorize this into its prime factors. 2 comes out and you get 125. And by now you should know that 125 is 5 cubed. So therefore, the number of factors, we've got a formula for this. The formula, the number of factors, the way to do this is you multiply, it's a product. It's a product of what? You take each index, there's an index 1 here, and you increase it by 1. Take that index, increase it by 1. And multiply all these numbers. Here you only got 2 prime factors, so you only have a product of 2 numbers. And this is 2 times 4, which is 8, as advertised. So that is the other way of solving this problem. Okay, so the next problem is a toy shop has one bag which contains 50% red and 50% yellow marbles and so on. So there's a big story here. And there are 3 bags. So I'm going to, you already know the story, so I'm not going to go over this. Let's just draw the bags. Oh, I don't have to do that. I have a neat way of drawing these things. So imagine that these are your bags. You know, I was always scared of technology all my life. I shied away from it. But now when I start using this thing, it's so beautiful. I've never ever drawn a diagram, a rectangle so beautifully. So I'm very pleased with technology at the present moment. Okay, you got 3 bags, 50% red, 50% yellow. So look, they say all the bags here have got the same number of marbles. So let's assume that all the bags have got 100 marbles, because then you can work out the exact numbers. So each bag has got 100 marbles. Okay, now, so that I don't know whether any one of you made that start. If you did that, then you'll still come to the right answer, because they didn't tell you how many marbles there were. So it doesn't really matter how many you put. You choose a nice suitable number, so you can work out what 50% of it is. So you can see you got 50%. 50% red, and here you got 25%. Let me just draw these things like this easily. And then you got 40. Or in other words, you got 3 different types of marbles. Okay. Let me just put down the numbers here, what's inside here. So 50% red. Let's just put 50R. And here you got 50Y. Right, so that makes you 100 marbles in the first bag. The second bag, you got 25R. Let's put that R at the bottom. And 75 yellow. Just draw a nice diagram like this to gather the information in the form of a picture. That helps a great deal. And then you got 21 red, 21R, 40 blue. Where did that come from? But you got 39 yellow and 40 blue. You can make a quick check to see that this works out to 100. So now they say what percentage of the marbles will be red if all the marbles are put into one bag. So all these marbles are shoved into one bag, and you want to know what percentage of the marble. Let's make the bag nice and big. So when you put everything inside there, we need to know what let's just put make these lines. Right, now when you put everything together, so how many reds are there? Well, you got 50 and 25 is 75. Oh, this is also red here. 50, 75, 96. Well, the question is, how many red? So we can put the red, and we're not interested in the others. You got 50 plus 75, 96. Right, so you got 96 red, and they want to know what the percentage of the marbles is. So to work on the percentage, you have to know how many there are altogether. But you got all the marbles being put together in the one bag, so you got 300 altogether. So 96 of those 300 are red. So what's the percentage of the reds? So it's 96 divided by 3, right? So its answer is 32%. 96 over 300 times 100 over 1, if you want to do the full thing. So that is why I said the hundreds cancel, so it's 96 divided by 3. So that's the answer. 32% of the marbles are red. Okay, so let's get on to the next question. A fish has mass 75 kgs plus 1/4 of its mass. Now, how do you translate that into an equation? The mass of the fish is 75 plus 1/4 of its own mass. What does this mean? Okay, let's say, let the mass of the fish be x. Let's translate this. The fish has mass, the mass of the fish, which is x, doesn't matter, is equal to 75 plus 1/4 of its mass. 1/4 of its mass is that. So that's the first equation. And this is, you can solve this easily. It means that x minus x over 4, bring all the x's to one side, equals 75. Then you get rid of fractions, you put 4x minus x, multiply right throughout by 4. That's how you get rid of fractions. Your 3x equals 300. X is 100. Now, this is how you use mathematics to calculate the mass of the fish. So the mass of the fish is 100. But if you use a common sense, you will say, well, look here, the mass of the fish is 75 plus 1/4 of its mass. But 1/4 of its mass plus 3/4 of its mass will give you its own mass. So this 75 represents 3/4 of its mass. So if 75 represents 3/4, then what is that number? Which number is such that 3/4 of it is 75? The answer is 100. Right? So that should be, if you just argue it out like that, you'll see you can get the answer very quickly. But the mathematics tells you that, you see, when you get this, you get 3. This is 3/4. So 3/4 of the unknown is 75. That would, mentally we can say that the number has to be 100, but you still use mathematics to get to that. Okay, now likewise, the other one, if you do that, you will see that the fisherman, I'm not going to do it, you do it the same way, you'll see that his mass is 125. And the mass of the fish is 100. What is the difference between their masses? So 125 minus. It's 25 kgs. When people set questions, they must set reasonable questions. This looks like one of those tall stories about fishermen. You know, fishermen are notorious for telling long, tall. What is the size of the fish you caught? They'll stretch their hands to 3 times the actual size. You caught a fish which is 100 kgs, guys. It looks more like a whale. People who set questions must be a little bit reasonable. Okay, so let's clear these drawings and get to the next question. Oh. All right, number 8. We've seen this kind of a thing. There's an operation, right? An operation is where you have 2 symbols to create a third symbol. So yeah, you see operation, they say addition is an operation because you need 2 symbols to create a third symbol. Multiplication is an operation because you need 2 symbols to create a third symbol, which is 15. So whenever you have 2 symbols creating a third symbol, by some rule, then you call it an operation. So the addition operation is x star y is x plus y. The multiplication operation is x star y is xy. Here you got some other formula. All right. So for how many real numbers is 24 equal to 8 star y? So you have an equation and you're going to solve for y. Right. Now, x star y is that, so x is 8 in that formula. So I have to put x to be 8 in that formula. You get 3 times 8 minus 8y plus x is 8y. Okay, so you bring all the y's to one side, and minus 8y, 8y minus 8y to one side, and there on the other side you got 24 minus 24, and you got 0 equals 0. Oh God. What's going on here now? This is my
Doesn't this mean that all natural numbers work?
So wouldn't the y's cancel each other out?
Yeah, right?
Y's cancel each other out.
Does this mean that all natural numbers work?
Yeah, it means all natural numbers work. You see, the thing is, it's not easy to conclude that, because when you do it in the normal way, right, you get 0 equals 0, and you wonder how you're going to translate that. Right? Some people might put 0, y equals 0, and y equals 0 over 0, which is really nonsense. Some people might say there's no solution. But the actual reason is that it doesn't matter. You see, what we've got here is, in the end, you got that no matter what y is, you get a true statement. 24 equals 24 is always true. 0, 0, 0 is always true. And it doesn't matter what y is. You will always get a true statement. So therefore, the value for y is quite random. Any random number will make this equal. So how many have you got? The answer is infinitely many. There are infinitely many real numbers. You can substitute any number you like. I think in the choices they say more than 4. And that would be the correct answer. Right? There are many, many answers. Okay, so that's, you see, when it comes to equations, let me just digress a little bit. And give you a small lesson. You know, it's a when you go to university, you'll have a situation like this: ax equals b, and you ask to interrogate this. What's the solution to x? The answer is not easy. If a and b are not given, there's no answer, no clear answer. We know if a is not equal to 0, as we just said earlier on, then we can say x equals b over a. So there you got a unique answer if a is not equal to 0. Then the question arises, what happens when a equals 0? Okay, now you have 0, x equals b, because a is equal to 0. Now you might say, okay, look, come in. Thank you.
You're welcome. On the light on?
Yeah, leave it on. So the if a equals 0, you've got this, but now that makes b equal to 0. But nothing was said about b, right? So now you have to say, what happens when a equals 0? If a equals 0, there are two cases. Either b is not equal to 0 or b equals 0. For instance, you could have had 0x equals 5 or 0x equals 0. See? So if a equals 0, there are two cases. In this case here, we just saw 0x equals 5. If 0x equals 5, that means 5 equals 0. which is nonsense, right? So B not equal to 0 gives you a nonsensical statement. So here there are no solutions when B is not equal to 0. When B equals 0, this is what we just saw now, 0x equals 0. Here, this means that infinitely many solutions, because any real number can be substituted into this and it makes it true. 0x equals 0, x equals 153 is a solution. So because 0 times 153 is 0. So this has got infinitely many solutions. Here you got no solutions. And here you got one solution. So the number of solutions is either 0, that means no solutions, or 1, or infinitely many. For the simple equation here. See? So you might think, oh, this is such an easy problem, Ax equals B. If A and B are given, then there's not a problem at all. Well, actually, it can be a problem if 0 equals 0, for instance. People find it very difficult to appreciate this. When they come to 0x equals 0, they say 0 equals 0. You shouldn't do that. You should stop here and say, which x satisfies this equation? Everything. See? All right, so that is a little digression, and I went on it quite fast, but I do hope that you benefited a bit by that discussion. Okay, let's go on to the next problem, which is problem number 9, I think. There we are. Okay, so here you got each side of a cube is increased by 50%. By what percentage is the volume of the cube increased? Okay, so what do we have here? You have a cube and each side is increased by 50%. Maybe it's a bit too big, but whatever. Now, by what percentage is the volume increased? So we know the side, so there's your cube. Ooh. This side there looks like the front of my car at the moment. Okay, usually I've got this habit of knocking everything in sight. So you got we don't know what the side is. So just give a name to it. So maybe you can call it X. Right. Now, the volume, we need to know what the volume of this is. The volume for this is x cubed. Volume of a cube is length times breadth times height, and all of them are equal in a cube. Now the side is increased by 50%. Now what does this mean? It means that the original side is increased by 50%. We saw something like this last week. It's 1 plus 50 over 100. Actually, it's x original plus 50% of x. X is increased by 50% of itself, right? And if you take x out, you get this. When you simplify this, this is 1 comma 5, which is 3 over 2. So when it's increased by 50%, then I need to get rid of that disgraceful object. Okay. Sorry, but it just pains me to see such a terrible straight line. So now you got 3x over 2, and all the sides are 3x over 2. So the volume here now is 3x over 2 all cubed. Okay, so the original volume is x cubed, and the new volume is 3x over 2 all cubed. And the question is now, the question says, by what percentage is the volume increased? Now, you have to be very careful here. You have to ask, how do you calculate like that? Like for instance, now, suppose I had numbers. Suppose I ask you to increase 200 by 10%. You will have no hesitation in telling me, well, 10% of 200 is 20, so the answer is 220. Right? Now, suppose I tell you the 200 has increased to 220. What is the percentage increase? How do you get back your 10% from here? You know the 200 has gone to 220. Well, the answer is, you see what the increase is. The increase is actually 20 from 200, right? And then the percentage increase will be 20 over the original times 100 over 1. So that will be, your actual increase is 20. You put it over 200 and do this. And when you do that, you will see the 100s cancel, 2 goes into this, and you get 10. And you retrieve your 10%, you see? You still get back to your 10%. So the idea is, you see what the increase is and put it over the original. So we're going to do exactly that. See, mathematics consists a lot of, you have processes, you know how to work with numbers, but then when you have symbols, you start floundering. That is why this question here was given. See whether you can extract exactly what you are doing when you're increasing something by some quantity. So the new quantity is 3x over 2 all cubed. Your old quantity is x cubed. And you're going to divide that by the old quantity and multiply by 100 over 1, right? Your new quantity minus the old quantity. And that will give you the answer. Okay, I've got fractions at the top here. I've got 27 over 8. I'm going to make this 27 over 8, x cubed. So the x cubed comes out as the common factor. So you have 27 over 8 minus 1 over 1 times 100 over 1. The x cubed, I'm taking it out as a common factor. And now this thing here is 3 and 3/8. When you subtract 1 from 3 and 3/8, you got 19. Okay, 19 over 8 times 100 over 1. And when you work this out, you get 237,5. Okay, so that's the answer. You see the increase divided by the original, multiply 100 over 1, simplify, and you get this. And we just seem to see how many of you actually got this answer. How many of you chose? By show of hands. Phoebe, very good. Daniel, very good. Okay, Michael also. Okay, so it's not bad. We had a fair number of people. It's a tricky question where you have to understand, what do you mean by saying that I'm calculating an increased percentage? So this interrogated that. Mathematics is about understanding, you see. And you know that certain processes are involved when you are doing with numbers, and you must extract those processes when you're working with general things. Mumtaz, you got a question? Or you are saying that you got the answer? You must put your mic on when I ask you a question and answer me, okay? Your mic is in the bottom left-hand corner. It's scratched off, right? A little microphone. So when I ask a question, just tap on that. It releases the sound, and then you can speak to me. And then after that, tap on it again, and that makes it mute again. Okay. All right. Okay, so the next one is, what are we doing now? I'm going to share the screen. Okay, so we now go to that. I am fortunate that my wife brought me a nice cup of tea, so I can bring it along. What number? In number 10. We are halfway through. Okay, why don't you take a quick break? Take a break for 4 minutes, 5 minutes. Go and quickly get yourself a cold drink or something, and then come back. It's 1 minute to 10 now. We'll start again precisely at 5 minutes past 10. Okay. There will be people who are staying behind. If you want to ask me some questions. Hey, nobody left. There are still 35 participants. Hooray. In that case, I can just continue. All right, nobody wants to go. Now I'm going to continue, guys. Would you pardon me while I rudely sip my tea while I talk to you? This problem here, you got this shape. They call this a monster. I don't know, a long time ago, when my son was young, he used to play this game. At that time, it was called Pac-Man. Do you still have a thing called Pac-Man? Is there a game called Pac-Man? All you game fans?
You get some retro versions, Prof.
Oh, you got new other versions, huh?
Yeah, new other versions. The older one, you can only find in arcade machines, the original one. But people have made digital ones that you can download.
Other things, yeah. They made that rather harmless little Pac-Man which went around into a monster, because that's what they are doing to young kids. They want them to have the feeling that they are some huge monster devouring everybody and creating all these violent thoughts in them. They make much more money that way. Hope you guys understand that these big money makers are exploiting you. Okay, the question is, what is the perimeter of the monster? The perimeter is nothing more than the total length of the boundary. The total length of the boundary of this thing. And the boundary is, so you want to know what this entire length is, including this. The radius is 1, so we already got a 1 here. So that is 1, and that is 1 here also. So these two parts of the boundary are already in. They add up to 2. So the question is, what is the remaining part of the boundary? The remaining part of the boundary is a circumference, but it's not the full circumference. The full circumference would have been all that. So this part has been taken away. is being removed from the full circumference. Now, what was the full circumference? The full circumference would have been 2 pi r. The radius is 1. So this full circumference is 2 pi, but we removed this part here. This part here, if this is 60 degrees, then this whole thing is 360. So 60 is just 1/6. So this part here is just 1/6 of this whole thing. So it stands to reason that this is 1/6 of the full circumference. Okay, now this is the that part there. So in fact, it's 5/6 of this. If you simplify this, you get 5 pi over 3. If you simplify this, you're subtracting. Common denominator 6 or whatever, you can just simplify it. We'll do it as a fraction, and you will get to this. So therefore, the perimeter of this is, don't forget the 2 radii. So it's 2 plus 5 pi over 3.
Professor, I don't completely understand that. Can you maybe explain it again?
Okay, Phoebe. So we needed to calculate the boundary, the length of the boundary. This length here is obvious because they say the radius is 1. Right? Okay, now we need to calculate this whole thing. See, maybe if you want, you can say this piece here makes 60 degrees, right? If you got a pizza pie and you cut off this piece here, what fraction of the pie have you taken out? Maybe?
6.
1/6, right? Yeah, correct. It's 1/6. You can see it. If you're eating a pizza, you say, I'm taking off 1/6 because this is 60 degrees, right? So 1/6 of this has been removed. So how many of that remains? 5/6, right?
Yeah, 5/6.
So 5/6 of the circumference remains. I'm sorry. Now what is the full circumference? The full circumference is 2 pi. This is 2 pi r. That's what I've got here. I just made it a little bit more complicated here. But this is 2 pi minus 1/6 of 2 pi. So that is 2 pi into 1 minus 1/6. And that's where the 5/6 is. Maybe I should have done it like that. And then now when you take this, 2 goes into 6 3 times. 5 times pi over 3 is 5 pi over 3. That's what I got here.
Thank you, Professor.
Okay. All right. My pleasure. So let's just get on to the next one. That's very good. I'm so glad that PB said that she didn't understand it. If you don't understand it, you must let me know straight away. Don't feel shy. Nobody can see your face, so you don't have to feel embarrassed. Okay. While I was talking, I was thinking about that line which I was supposed to draw a straight line for that cube. And instead, I do something that was quite nasty. I did that. It reminds me of something that I read a long time ago. Try to explain to me what this picture is. What does that represent?
I don't know, Prof.
All right, you don't know. Anybody wants to take a wild guess? Why is my thing not coming on?
Prof, is it a puddle with a bunch of footprints surrounding it?
Ah, that's, we're getting somewhere there. We're getting somewhere there. Why is this not writing? Oh. Sorry, something happened to my pen. I'm not sure. Once I was able to you see, this pen of mine has got two buttons here, which I don't know what they mean. So as I was writing, I think I pressed one of those buttons, and
Prof,
okay.
you just changed your color of your pen to white.
Oh, I changed the color to white. Okay. No. I've changed it to black again, but okay, that is a good. Ah, okay. Yeah, I think you're right. All right, so this is a puddle. Well, let me give you a clue. This actually it is a drop of beer. So what are these? One of the bad things about online teaching is that you can't hear your students laugh, or you can't see their faces, so you don't know whether anybody understood this joke. So, so it's a group of ants. Ants are very, very organized, and they walk in straight lines. All right, let me just get on to wasted enough time here. Get on to the next problem. The next problem is a geometry problem. And it says here, in a right angle triangle ABC, the two sides are given, 5 and 12. I think by now you should know, in a right angle triangle, if two sides are 5 and 12, then the hypotenuse is 13. This is a well-known thing. Okay. And then at A here, you draw an arc like this. And at B, you draw another arc like that. And the question is, if these arcs intersect the hypotenuse at M and N, then what is this length here? What is the distance from M to N? Now, this is not a difficult problem at all. If you just use some common sense, the full length of this is, as we said earlier on, is 13. Square root of 5 squared plus 12 squared is square root of 25 plus 144. This is square root of 169, which is 13. All right, so the full length of that is 13. We don't know what this question mark is, but we do know that there's a circle here. So AC is a radius of a circle, and it's the same as AM. So the distance from A to M, AM, is 12. But we know the whole thing is 13, so we can safely say that this is 1, that part. Okay, because this part here is 12. Now likewise, you've got this part here is 5, so therefore that part is 5. And the whole thing was 13, and this part here is 5, so this part is 7. And straight away you got the...
Sir, shouldn't it be 8 instead of 7?
Yeah.
Because it's 13 minus 5 is 8.
Oh, 13 minus, yeah, the whole thing is 13, and you're taking away 5. Yeah, so this is 5 here. The whole thing was 13, 8. Yeah, thanks very much for that. So you got 8 and 1 is 9, and the whole thing is 13, so your question mark must be 4. All right. How many of you got 4? Okay, good. I can see a fair number of people are getting it. It's not a difficult problem, but you see, you have to think now, what do you mean by a circle? Which lines are equal? This is a center, if this is 5, that has to be 5. You put together all the piece of information that you've got, but you must gravitate towards your answer. This is what we are going towards. So this little thing, if you know that, and if you know that, you know the whole thing, then you are there. So that is what we were trying to do here in this problem. Okay, so let's just clear the drawings and get to the next one. Okay, so the next one is this thing here, the cube root of the cube root and so on and so forth. It looks so horrible. Well, it's some power of p, and you need to know what the power is. You need to know what n is. We can do it like this. Look, the cube root of something, if the cube root of x is 3, what is x? $27, right? Because the cube root of 27 is 3. But the correct answer will be x is 3 cubed. Where cube root means you're multiplying something by itself 3 times. So when you cube this, you'll get to your x, right? So your x is 3 cubed. Now, if I start with this, if I want to get rid of the cube root here, then I can just take the inside, which is p times cube root of p times cube root of p again. I'm going to cube this entire thing, and I get p to the power of n all cubed. Now, p to the power of n all cubed is p to the 3n. All right, now let's have a look at this one here now. This is p it's equal to p to the 3n is equal to this. So let's divide by p, because I've got a p outside here, and that is equal to cube root of p times cube root of p. All right, now I got a cube root of something here. This part here, I can use my laws of indices to say it's 3n minus 1, because this is p to the 1. So I got p to the power of 3n minus 1 equals, again, it's equal to the cube root of something. So once again, you cube both sides. It's equal to the cube root of something, but the something is this. Okay. So I'm running short of space here. This part here, using the third law of indices, is p to the power of this multiplied by this. So this is p to the power of 3n minus 1 times 3. And when you expand that, you get 9n minus 3. 3 times 3n minus 1. So I got p to the power of 3, 9n minus 3. On the left hand side. And that is equal to p times something. So let me divide by p again. And you're left with cube root of p. Okay, again by the third law of indices, this gives you, second law, 9n minus 3 minus 1 is 9n minus 4 is equal to cube root of p. And once again, I'll cube both sides. That's equal to the cube root of p. I'll cube both sides, I'll come to p. And then finally, let's just create some space here. I've got, this is the equation that I got here. I cubed 9n minus 4. So that'll give p to the power of 27n minus 12. Sorry, 27n. 3 times 9n minus 4 minus 12 here. And that's equal to p. So that's p to the 1, you see. So now you got the same base, so you can equate the indices, and you have your equation in n. 27n is equal to 13, and finally you have n is equal to 13 over 27. So that's the answer. Now, this method here actually exploits the meaning of cube root. Every time I have something as a cube root, then I just cube it to get to what's inside. It's a little bit messy, but you will get the solutions in time so you can study it, but you can try it out on your own again. Okay, there are 3 people who raised their hands. Tell me. Anyone, you can just open your mic and ask me your question. Oh, you got the answer. Oh, I presume that people were anticipating how many of you got 13 over 27. I see 3 originally. Come on, let me see. How many of you got 13 over 27? Oh, it's increasing rapidly. Very nice, very nice. That wasn't an easy problem. Oh, 11. 12. Ooh, ooh. Okay, that's very, very good. That was an easy problem. Okay, let's get on. The next problem is a sequence is formed by repeatedly multiplying it by a constant factor. See, those of you who are familiar with geometric sequences will know this. But since I think this is a kind of a stupid question. People want to test something on geometric sequences, but not everybody knows it. So they put it in this language here. Anyway, a sequence is formed by repeatedly multiplying by a constant factor. Now, what does this mean? Now, for instance, you're starting by 54, you multiply it by something to get 36. Constant factor. You're multiplying by some number to get 36. Now, if you think about that, what must you multiply to get 36? That's not easy, but it's actually 36 over 54. It's a fraction. If you multiply this by 36 over 54, sure, the 54s will cancel and you get 36. So, but this is nothing else but 18 goes into this. If you simplify this, you get 2 over 3. So you're multiplying by 2 over 3 to get this, right? 2/3 of it. 1/3 is 18, 2/3 is 36. Now let's see, if you multiply this by 2/3, 1/3 is 12, 2/3 is 24. 1/3 is 8. 2/3 is 16. Oh, no, 1/3 becomes a fraction here now. So let's just go on like that. That is why these people stopped. You see, you got the same numbers. So you're multiplying by 2/3 right throughout. So you want to know the 10th term. Okay, now that's going very far away now. If you work out the 10th term, you can imagine it's going to be horrible because you're going to multiply it by 2/3, then you're going to multiply that by 2/3 and 2/3, and you get horrendous answers. So instead of doing it like that, what I would do is I'll say 16. I won't simplify it. I'll say 2/3 is the next one. 16 times 2/3. The next one, you're multiplying that by 2/3. So just put 2/3 squared because you're multiplying 2/3 times this. 2/3 occurs twice. So this is the 5th term. So this is the 6th term and the 7th term. The 7th term will be 2/3 cubed. The 8th term will be 2/3 to the power of 4. The 9th term will be 2/3 to the power of 5. The 10th term is 2/3 to the power of 6. And that's exactly what we wanted to get to, the 10th term. So the 10th term is, so you don't simplify, you just keep multiplying by 2/3 and put them as powers. So the 10th term, according to this, is 16 times 2/3, all raised to the power of 6. Okay. Now, they say it's 2 to the a over 3 to the power of b. So let's write 16 as 2 to the power of 4 times, now 2/3 to the power of 6 is 2 to the power of 6 divided by 3 to the power of 6. 2 to the power of 6 divided by 3 to the power of 6. And that gives you 2 to the power of 10 over 3 to the power of 6. And you've got it in the form that we wanted. 2 to the a over 3 to the b. So this must be a, and 6 is b. And the question is, what is the difference between a and b? 10 minus 6 is 4. So that's the answer. So this problem tests indices. You could have used the geometric formula and all that, but you don't really need to. As you can see, I did it without using any formulae. I just kept multiplying by 2/3 until I come to 10. But after a certain time, I said, I'm not going to multiply. I'm just going to take x times x is x squared and use that thing to eventually get to the answer. Okay. So the next problem, let's just clear this thing. Is this the problem? Which? Okay, this 13. Okay, now we go to 14. The sketch below represents a section of a regular polygon. Now, remember what a regular polygon is. A regular polygon is a polygon with all the sides equal. Last week, I gave you an important fact somewhere, and I told you about polygons. Now, if you recall, I told you that if you've got a regular polygon, all the sides are equal and all the angles are equal. Right? But for any polygon, I mentioned an important fact, and I told you that the sum of the exterior angles is always 360 degrees. So that is an important fact. I'm mentioning all these things because whenever you got polygons, you can be rest assured that that fact will come come up. The sum of the exterior angles is 360 degrees, regardless of the polygon. Now here you've got a polygon here with very large interior angle. All these angles are equal, but they seem to be almost straight here. The size of angle BDC is only 10 degrees. So if you join DC, now what is it? BDC, BDC. So I have to join BD. So this little angle here, which is almost invisible, that is 10 degrees. Right. Now how are we going to make use of this? Okay, before we go on, the question is, what is the perimeter of the polygon? To get the perimeter, that means you need to add up all the sides. I see quite a lot of questions were involving perimeters. So you add up all the sides, and all the sides got length 1. So the perimeter is just the number of sides times 1. So let's just say, let n be the number of sides. We don't know how many sides there are. So the perimeter will be equal to n. If the n sides, each one is 1, so the perimeter is n. So we need to work out the number of sides. All right, now we know in a regular polygon, all these exterior angles are equal, right? All of them exterior angles are equal. So if I say, let the exterior angle be x, they're all equal. Then according to the statement here, you got, because it's regular, all the internal angles are equal, and therefore the external angles are equal also. So all the exterior angles are equal to x, right? All the exterior angles. So I can say, let exterior angle be equal to x. The n of them, we said there are n sides, so there will be n exterior angles. So when you add up all the exterior angles, you're going to get n times x plus x plus x, n times. And we just saw that the sum of the exterior angles, that's what I was trying to do. I'm adding up all the exterior angles. We know it's 360 degrees. Okay, so we need to calculate the number of sides. So n must be equal to 360 over x. That will be the number of sides. So now the problem reduces to, what is an exterior angle equal to? And this little thing, they tell you that this is 10. This tiny little fellow here, which is almost invisible, is 10. But remember, this is a regular polygon. So these two sides are equal. All the sides are equal, right? So this is an isosceles triangle. So it means that this other little fellow is the same as his brother here on this side. And now to get the exterior angle, now you see, it allows us to get the exterior angle. All I have to do is to extend that BC when I extend BC, then I get this thing here. That's my x now that I'm speaking about, right? I said, let the exterior angle be x. So this x here, now from this picture, you can see that x is actually equal to 10 plus 10. It's your Pillay theorem. There's a straight line here, straight line. The interior opposite angles are 10 and 10. So x is actually 20. The exterior angle. And now that allows you to calculate the number of sides from a previous discussion. 360 divided by 20, because x is now the exterior angle. The sum of the exterior angles is 360. Cancel. 2 goes into 36 18 times. So the number of sides is 18. So let me see. How many of you hit the jackpot with that one? Quite a tough problem. Oh, it's increasing. 6, 7, 8. Okay. 12, 13. Oh, that's very nice. I'm so glad, because it means that you are making good use of the fact that the exterior angles of a polygon is 360 degrees, and you use that information. Thank you very much. Okay, now we need to get on to the next problem. Okay. Abby and Zelisma are running to get fit for a road race. All right, they are explaining why they are running. They could have been running away from police. Although it's got nothing to do with the problem, but still, it's nice to know. Abby starts running 2 minutes before Zeliswa. Let's just put this to a diagram here. And imagine this road is a straight line. I want to understand this problem. So let me draw the road first. So Abby starts running 2 minutes before Zeliswa. So Abby starts running. Zeliswa stays still, allowing Abby to run for 2 minutes. Now, the moment Abby had finished 2 minutes, then Zeliswa starts running. Right. Now, the speeds, the Abby speed is 11. And Zeliswa's speed is 13. Okay, so Zeliswa is traveling faster than Abby. So at some time or the other, Zeliswa is going to overtake Abby. She's traveling, although she's got 2 minutes fast, but she's going to overtake her. Right, because she's always going to be 2 kilometers per hour faster than Abby. So they're going to meet somewhere. And the question is, when she catches up, suppose they catch up here. This is where this Zeliswa and Abby are together at the spot. Right. Now the question is, how many minutes will it take Zeliswa to catch up with Abby? These same problems can be quite tantalizing. Distance time problems. Most people find it very difficult. Teachers very rarely do teachers teach this because they get scared of it. Because the thing is, you have to decide what your unknown is going to be. That is really the huge problem. Now, and to decide what the unknown is going to be, you have to have some equation, so that you can solve for the unknown. And this is the observation. You see, when Abby started running, Zeliswa. She started running when Abby was there. From this point, if you put the stopwatch on here, right, it will be at 0, a stopwatch. And then when she starts running and she puts the stopwatch on, then she goes on, and then eventually she catches up with Abby. The important thing here is that we don't know how long it will take for it to get there, but suppose it took a t minutes, because that's the question. How many minutes will Zeliswa take to catch up Abby? So let t be equal to this. T. Now you got kilometers per hour. So I'd rather make this hours. And I'll tell you why. Because I want to know how far Zeliswa traveled in t hours. I know airspeed is 13 kilometers per hour. In 1 hour, she travels 13 kilometers. So how far has she traveled in 1 hour, in t hours? So she would have traveled, the distance she would have traveled would be 13t. In 1 hour she traveled 13 kilometers per hour. That's what it means, per hour. So in t hours she will be traveling 13t kilometers. So this is the distance now. This is the distance. Right. But actually, we're really not interested in that. I'm sorry. I'm more interested in what Abby has traveled. In that time, Abby would have done 11t. But Abby would have had 2 minutes extra to travel that distance. The full distance here, from here to here, Abby had 2 minutes extra to get to 13t. Now she's traveled for t hours, and 2 minutes, you have to convert that to hours. That's 1/30th of an hour. So Abby, as her time on the road was t, but then she had this amount of time to travel altogether because she traveled for this amount of time. See? When Zuliswa had t minutes, she had more time. That's the point. She had t plus 1/30 to travel the same distance. So the distance she traveled was 11 times that, because the number of hours she traveled for was that. So therefore, the total distance she traveled would have been that. So therefore, these distances are the same. 13t is actually equal to 11 into t plus 1/30. And if you work this thing out, you'll see you get 13t minus 11t is 2t. 11 times this is 11/30. So therefore, 2t is equal to 11/30. So t is equal to 11/60. That's the 11/60 hours, remember? We're working in hours, which is the same as 11 minutes. So the answer to this problem is 11 minutes. Some of you would be saying, hooray, I got it. And others would say, oh, what happened? But it's a tricky problem, I must say. It's a very tricky problem to understand exactly how to get the equation. See, you have to get something which is constant. Both of them traveled for the same period of time. They didn't travel for the same period of time, but one traveled for more time than the other, but they traveled the same distance. That is the important thing. They traveled the same distance because both of them started from here and they landed at that spot. So they both traveled, they covered the same distance, but in different times. So that is how you get the equations. Now, anybody got 11? How many of you chose 11? 9. Okay, so we've got a very good, larger number of people. You only need 50% to get into round 2. So if you got 10 out of 20, you're on your way. That's a nice thing. All right. But there would be many people in the country will get 100%. We always see that. So there's some bright kids. Okay, now the next problem we want to go to is, what is the units digit of this? Okay, you are multiplying 1846, 1846. Let's multiply this whole thing out. 82 times 1846. The 82 of these. And then you're multiplying 107, 1007, 1007, 82 times. Okay, now, so when you multiply these digits, now you got the units digits. If you just track the last digits, you're getting 6 times 6 times 6 times 82 times. And here the units digit is 7 times 7 times 7, 82 times. You got the same power, right? Now 6 times 6 is 36. So if you multiply 36 by 6, you still get 6. So the last digit is, for this number here, or the units digit, is 6 for this part here. So the last digit of that monstrous number is 6. So we need to know what the last digit of this is. All right. Now this is going to be a problem because we need to check what happens to 7 times 7 times 7 times 7 times 7. Let's put quite a few to see what's going on. And you go all the way, and there are 1007 of them. No, not 1000, 82 of them. Right. Now, if you take 7, the last digit of just 7 by itself is 7. When you come to this 7 times 7, the last digit is 49. When you come to this 9 times 7 is 63, the last digit 63. 7 times 7 times 7, the last digit is 3. It's actually 343. Some of you will know, but the last digit is 3. The last digit of this 3 times 7 is 1. The last digit of 1 times 7 is 7. The last digit of 7 times 7 is 9. The last digit of this is 3. This is 1. Now you can see the last digit is 7 times 9 times 3. It's either 7 or 9 or 3 or 1, 7 or 9 or 3 or 1. It's going to be one of those. But it all depends on how many you are multiplying. I'm multiplying 82 of these. And when I multiply 4 of them together, you see, then the last digit is 1. When I multiply another 4, the last digit is 1. I like that because 1 times 1 times 1, we know what that is, you see. So if you start multiplying them in groups of 4, you're going to get the last digits are going to be 1 times 1 times 1. That helps me a great deal. But you've got 82 of them. So the last, you'll have, in groups of 4, you'll have 80 are knocked out, right? 4 times 20. And you're left with only 2 7s at the end. And you're going to have 1 times 1 times 1 all here. But this last 2 digits will give you 7 times 7 is 49. And gives you 9. So the last digit of this monstrous number is 9, because the 82 of them, when you group them in 4s, the last digit is 1, so you have several 1s, and then you're left with only 2 because you've got 82 altogether. Those 2 will be, the last digit of that will be 9. So in the end, you got the last digit of this is 6, the last digit of this is 9, and so therefore the last digit of this entire thing is the last digit of 6 times 9, which is 54. So the very last digit is 4. That's the answer to the problem. Okay. Now, you see, you can guess the answer, and there is a 20% probability of getting the right answer, right? So there is 20% of the people would get the right answer if they just take a random guess. But the important thing is, no, without guessing, could you have calculated it? All right. Look, it'll be nice for you to go over this thing again to understand exactly. You have to understand it. You have to know what is Prof doing here. We're only tracking the last digits, and you can take as many products as you like. You can track the last digit, and in the end, you can get to the answer. That is what I was doing. Okay. All right, let's get on to the next problem. We are at problem number 17. We've got 12 minutes. I think we can make it. 3 balls marked 1, 2, and 3 are put into a bag. A ball is drawn at random. Oh, so this is a probability problem. A ball is drawn at random, and the number is recorded. And then the ball is returned into the bag. This is done 3 times. And each ball is equally likely to be drawn on each occasion. Okay, that's understandable. You close your eyes and you're just putting your hand into that. You don't, it's marked 1, 2, and 3. So you cannot distinguish between the balls. So you don't know which one you're picking up. Okay. All right. Now, what is the probability that the sum of the numbers of the 3 balls drawn is 6? Now, you probably will have no idea where to start with this thing here. But we need to see what's going on in this and see what are the possibilities. What I'm going to do is I'm going to say what are the possibilities for the 3 draws. And you got draw 1, draw 2, and draw 3. Okay, what are the possibilities? Then they are marked 1, 2, and 3. I could have started off with 1, 1. Let me just look at the first 2. Then I could have had 1, 2. Or I could have 1, 3. Right? Okay, let's stop there for the moment. If I add 1, 1, this is where the draw 1 is 1. If the first one drawn is 1, then these are the possible ways of getting the first 2. And you can end up, the last one could be 1, 1, 1, 1, 1, 1, 2, or 1, 1, 3. The same thing here, 1, 2, 1, 1, 2, 2, 1, 2, 3. And the same thing here, 1, 3, 1, 1, 3, 2, 1, 3, 3. What does this mean? It means that if the first one was a 1, I've got 9 possible ways of getting the first one as 1. Right? You can take any one of these. 1, 1, 1, 1, 1, 2, 1, 1, 3, 1, 2, 1, 1, 2, 2, 1, 2, 3, 1, 3, 1, 1, 3, 2, 1, 3, 3. There are 9 of them. Likewise, you have a similar kind of an argument. If the first one was 2, there'll be 9 there. And if the first one was 3, there'll be 9 there. And the first one can be those are the only possibilities, 1, 2, or 3. And this exhausts all the possibilities. So there are 27, 9 plus 9 possibilities altogether. If you list all the possible things that can happen. Right. Now, let's get back to the question. They say, what is the probability that the sum of the numbers on the 3 balls is 6? So you need to isolate those numbers here which add up to 6. Right. Now in this group here, are there any which add up to 6? The first group. You can have 1, 1, 1, 1, 1, 2, 1, 1, 3. You can't. The most they'll add up to is 5, right? And in this group here, yes, you got 1, 2, 1, 1, 2, 2, 1, 2, 3. So there's 1 here in this group. And even in this group here, you got 1 here, 1, 3, 2. But just observe, when you get adding up to 6, now we have to ask ourselves, how can 3 numbers add up to 6? Well, you can have 1 plus 2 plus 3, or 2 plus 2 plus 2. That also adds up to 6. There's no other way in which you can add up to 6. So you need to have all of them are different, or all of them are the same. Now 2 plus 2 only occurs once here. Here, where it starts as 2, it occurs there, and that's it. It doesn't occur anywhere else. But when I say okay, when you say 1 plus 2 plus 3, that means I'm allowing 1, 3, 2. I'm allowing 1, 2, 3. I'm allowing 3, 1, 2. I'm allowing any combination of 1, 2, and 3 will be allowed. So how many such combinations have we got? Well, it's just the number of ways in which you can rearrange 1, 2, and 3, right? And if you can do it like this, you can say this is 2, 1, 3, 2, 3, 1, 3, 1, 2, 3, 2, 1, or whatever. If you count them, you'll see you get 6 ways in which you can arrange 2, 1, 3. So I just counted 2 of them here. One of them was 1, 2, 3, and the other was 1, 3, 2. But you could have had 2, 1, 3, 2, 3, 1, or you could have a 3, 1, 2, 3, 2, 1. Okay. So there were 6 there, and the 2, 2, 2 was another one which belongs, which is slightly different. That gives you the another one. And there are no more. The only ways you can add up to 6 is 1 plus 2 plus 3, or 2 plus 2 plus 2. So these give you 6 possibilities. These give you only one possibility. So 7 of these 27, right, add up to 6. So the probability of getting the sum 7 is 7:27. Only 7 of them are successes. That's the answer. Probability is something that you would do in metric. But you'll notice the way I argued here, it's all logic, guys. It's all logic. You don't need any formulae. You just have to think now, what's going on? How do I count? What do I do? What's the question? When you got 3 numbers adding up to 6, what does that mean? See, interrogating it and marching forward, right? You can get stuck somewhere, but you must just think again, and you know you're going to come plot forward. See? You could have written the whole 27 down and then see which one added up to 6, but you don't have much time. You only have 1 hour to do 20 problems. But if you did all the first ones quickly, but that'll take a long time. This argument, this logical argument, helps you to get very quickly to the answer without listing the whole 27. The whole 27 numbers. Okay, so the next problem is a geometry problem. We don't have much geometry problems. I changed the question because I wasn't very happy with the way the questions were phrased. So this problem here, you got a quadrilateral. So let's just draw this quadrilateral. The diagram is not given. Oh, the diagram was given in that quadrilateral, I think. But I'm not giving the diagram. With good reason. Okay, so it's some quadrilateral, and then one line is parallel to the other. So let's draw. Only one line is parallel, so let's just draw a trapezium here. Make sure this line is parallel. This line is parallel to this. And what else is given? It's given that maybe some of you never came to this problem. Let's just put PQ is parallel to SR. So PQ, oh, I'm sorry, PQ, R, S. So these lines are parallel. They say PQ is 5, PS is 4, and QS is 7. So it's that diagonal. The diagonal is equal to 7. Right, now they say that these are similar. What does that mean? It means that they got the same angles. Well, because they are parallel, we know that these angles are already equal. Right? So if you take the second angle, that angle there is equal to one of the remaining two angles. Triangles are similar means they got the same angles. Okay, already you've got one angle. These two triangles are similar. The top triangle and the bottom triangle. It says there. They got the same angle. So I took this angle here, call it x. I already know it's equal to this. Okay. Now if I call this y, I know it's equal to one of the two angles, but which one? Do you think it's this one here? Right, come on guys. I want you to ask, can it be that one?
No, it cannot.
Right, okay, Helen, that's a good answer. Why?
Because 7 is the middle length side of the other triangle.
Yeah.
So the corners can't audience them. Y has to be the other corner because it is on the longest side of the triangle.
You see, this longest side here, I just drew it like this. I don't know how big SR is. SR could have been here. You understand, Helen? I drew it like this, but I cannot use that as a fact now because I drew it like that. It could have been a short line. See? All we know is they are parallel. So don't assume anything that we are not given. We don't know that SR is the longer side. Okay, but that was a good answer. If SR was the longer side, then she is quite correct. But we don't know that. Anybody else wants to take a guess? What kind of angles are these? Look here. Alternate angles. Agreed?
Yes, Prof.
Yeah, these angles are alternate angles. So if they are equal, it means that this is parallel to this. Because the alternate angles are equal. Agreed? But we already know that this is parallel to that. So we will have a quadrilateral. If these were equal, this quadrilateral will be forced to be a parallelogram. Do you understand? So this y here, this angle here is not equal to that. Otherwise, you will have a parallelogram. And it's given, quite specifically, it's given that this is not a parallelogram. So y is equal to one of those two angles. It's not equal to that one. So therefore, it must be equal to the other one. Oy, what happened here now? Ooh. Something terrible happened here. I pressed something. Oh, thank God that worked out quite quickly. I get a heart attack every time something like this happens because I don't know how to manipulate these things. So we had these lines like that, but this is wrong now. Right? It would have been, oh, okay, sorry. So now I have to take out y from there. But y is equal to one of these triangles because the triangles are similar. It's not that one which you just chose. So it's now forced to be this. Right. So now the question is now, these triangles are similar. So I want to know what the perimeter is. Okay, so we don't know these sides here. So let's call these sides A and B. Now that we know that they are similar, right? Now this is usually done in grade 11 and 12. But look, you guys, I've spoken to you about similar triangles. It's very easy actually. Similar triangles are two triangles which have got the same angles. I like to think of this as a photograph of that. You got a big triangle as a photograph, and it means now that then straight away you should know that all these sides are being contracted in the same manner. If you knew that this is 8 and this is 6 and this is 10, right? And if this was 3, you can immediately say that this has to be 4 and this has to be 5 because the contraction is the same. If this is half of this, then that will be half of that and that will be half of that. In other words, the ratios of the sides, that over that is the same as that over that, which is the same as this over that. See? So bearing that in mind, I can now say that 5, let's take this triangle here, 5 over, right, 5 is paired off with y. 5 and y are pairs. When I say pairs, an angle and the side opposite it. Now what is paired off with y? The pair of y in the other triangle is 7. So I have to put a 7 here in the second triangle. Right? I'll say that again. The corresponding sides are 5 is opposite angle y. So therefore it must be paired off with the side opposite angle y in the other figure, and that is 7. Right. Now let's go on to 4. 4 is paired off with x. Yeah. So what is paired off with x here? It's b. And likewise, 7 is paired off with that remaining angle. So that will have to be a. Right. Now, there it is. You've got a single equation with one unknown. And if you look at it, 5b equals 28. B is equal to 28 over 5. And here, 7 over a equals 5 over 7. So 5a is 49. So a is 49 over 5. So they want to know the perimeter of this thing. So it's going to be 5 plus 4 plus a plus b. I don't know, it seems to me that I got something wrong here. But just check it out. I'm not getting a whole number. So there's a problem. The answer would have been a whole number. Okay, some calculation error. But I hope you understand what went on here. I don't have any time because I've already gone 6 minutes past the time. So just check it out to see where I went wrong. And all right. Okay, look, those who wish to leave, you can leave. Let me just stop here for the moment and talk to everybody. Okay, some people have already left. I want to just thank you for coming today. And lots of people have spoken to me on the chat column. I'll look at it later. But I just want to say that we won't be meeting again for the time being. Today is the last meeting. It's been very nice joining you guys to show you some pathways onto how to solve problems. We'll be coming back again on the 27th or something of April. So you got a long break. Now it's 13th of March. So in about 6 weeks time or so, I'll return. You will get the notification. Just keep an eye on it. When we come back, we'll be still looking at problems, but we're looking at more challenging problems, right? Because those people who come back, I want everybody to come back, whether you got into round 2 or not. That's not important. But what is important is you learn how to solve problems, even difficult problems. Don't bother about whether you got into round 2 or not. That's an immaterial, right? But as you go on, you see you'll become better and better. So next year, you'll be much better equipped to deal with Olympiad problems. So don't miss out on classes, okay? So we will meet again on the 27th of April or thereabouts. The South African Math Foundation will contact you, and then we will take it from there. We'll tell you how long we're going to meet, and so on and so forth. Okay, now before I will do 19 and 20 because I know some people want to know that, and others want to leave. But those who want to leave, do you have any questions? Anything you want to say? All right, but you can say it, whatever you want to say, you can say it in the chat column. And one of the things I'd like you to say in the chat column, those people who are already here, the 28 of you, is if you've been reading the book, I just want to get your comments on the book. Is it readable? Is it difficult? Hopefully you have been looking at my book. I'd just like to know, what the pitfalls are and what are the pluses and so on, so that, we have some sense. We always like to have commentaries on the book. And also the people who are selling the book will want to have some statements about those who read it. So then your statement might go into the website. So please just share your comments. Take a little bit of time to do that. You can do it at the end of the class if you want, but I just want to go through this last bit. I don't know how difficult those problems are. I've forgotten what they are. The last problem is usually a very sticky problem. Oh, we've done this. Oh, this one. Oh, yeah. Hey, wait a minute. That's 19. That's 18. Oh, this one. All right, I'll do this thing quickly here. 19 about license plates. It's that counting principle that we've been speaking about. The first counting principle and second counting principle. We've done quite a few of that. So, so you're making license plates, which with letters, like the counting people have two or four letters of the alphabet and two numbers, but the KZN have got only 2 letters and 6 numbers. So there are different ways of doing this thing. So there is a country which wants to use license plates, and they use all these digits. I just want to see what they are doing. The first choice was they got a license plate which consists of 2 letters by 4 digits. So you got 2 letters here, and then you got 4 digits. Right, and you want to know how many license plates can you construct altogether. And this is the first counting principle. And the way we did it was to say, okay, let's see in how many ways can you choose the first letter. This is a letter of the alphabet, and there are 26 letters. No, nothing is A to Z. And the second letter is also an alphabet. But here you got a digit, but there are 10 digits from 0. So there are 10 ways of choosing these 4 digits. All right? But then they say, okay, we want to change to a system which has got a slightly different format. Right? Again, you got license plates. But this time, it says the first 4 digits consists of 4 letters. So you got 4 letters in the front, and then followed by 3 digits. So you got 7 numbers now. Well, previously you only had 6, but you got 7 now. And the first 4 are letters of the alphabet. So, and there are many more choices. So therefore, you can make many more license plates. You can make many more because you got 7 digits, and you can choose more alphabets. Oops. You can choose more alphabets. So here you got, again, you got 26, 4 of them are letters of the alphabet, and only 3 of them are digits. So here you've got the total here is 26 squared times 10 to the power of 4. And here the total is 26 to the power of 4 times 10 cubed. That's the total number of license plates you can make in the second case. And in the first case, that's the total number of license plates you can make. And the question is, by what factor will the number of license plates increase? Now you have to translate that. If I say increase 8 by a factor of 3, the answer will be 24. If I say increase 11 by a factor of 10, then it's 110. So the new number over the old number will be the factor, right? 110 over 11, 24 over 8. So the new number is that over the old number, and that is what you have to do. And when you simplify this, you got, by using the third laws of indices, you got 26 squared there at the top, and you got 10 cubed and 10 to the 4th here. So you got a 10 at the bottom because you got more 10s here, and this gives you 67.6. It is by that factor that the number of license plates will increase. Okay. And then finally, the last question. Last question is usually a difficult question. So you got a figure which shows a quadrilateral ABCD with AB equal to 30 and CD equals 54. The diagonals are equal. So this is 56 and this is 56. The question is, what is the area of triangle ABZ? Okay. Now you got parallel lines here, and it means that this small triangle is similar to this triangle here. The small triangle is similar to, because the alternate angles are equal and the vertically opposite angles are equal. So the 3 angles of this triangle are equal to the 3 angles of the bottom triangle. We need to find the area, this area here, ABZ. Okay. All right, so what does this mean? It means that the sides are in the same proportion. You look at 54, what must you multiply 54 by to get 30? And what must you multiply 30 to get to 54? It has to be 54 divided by 30. Why am I asking that? I want to, if I call this X here, and if I call this Y, right? These two are similar, got the same angles, so the sides are in proportion. So what must I multiply this side here to get to that side? 54 over 30 is 9 over 5. So if this is, so the multiplying factor, if I multiply this by 9 over 5, I'll get this. So I must multiply this by 9 over 5 to get this, you see? Like that. And if you take this, you have to multiply this by 9 over 5 to get to that one. Because these two triangles are similar. But it's given that the diagonals are equal. AC is a diagonal, BD is equal. So they're both equal to 56. So when I calculate the diagonal, I get x plus 9x over 5 gives you one diagonal. And the other diagonal is y plus 9 over 5. Sorry, y plus 9y over 5. That's the other diagonal. But both these diagonals are equal, and they're both equal in length to 56. So you actually got two equations, but there's only one unknown here in this equation. Right? Yeah, I get 14 over 5, so this gives you x is equal to 20, I think. What is it, 14x over 5? Yeah. And the y is also 20. So this is the same equation. So x and y are both 20. So this is 20, and that is 20. So now the problem is, what is the area of this triangle? Right? The area of the triangle, now if you look at the triangle carefully, you'll see, I'll redraw the triangle. Two sides are 20, and the third side is 30. Because we calculated x and y. 20, 20, and this is 30. Now we need to know the area of an isosceles triangle. Area of an isosceles triangle whose sides are 20. And in one of my classes, I told you, whenever you've got an isosceles triangle, always split it down the middle. I gave you an important hint about isosceles triangle. That will help you to solve a lot of problems like this one. So now when you do that, you see this area comes out very easily now, because so this becomes 15, and this is also 15. When you're splitting an isosceles triangle, these two are equal, those angles are equal, these are 90 degrees. That's the nice thing about isosceles triangle. You can split it down to two right angle triangles. So now to find the area of this triangle, that is what we're trying to calculate, is half of the base, which is 15, the base is 30, times the height. Now the height can be calculated because you got the height is, you got a right angle triangle here, 20 and 15. So the height is square root of 20 squared minus 15 squared. Sorry, the area of the triangle is half base times height, and that gives you 15. The height is, this is 20 and this is 15. So the height is square root of Pythagoras. Square root of 20 squared minus 15 squared. You don't need to use a calculator here. You can take out the 5 as a common factor, but 5 squared comes out as a common factor. So the 5 comes out from the 5 squared. Square root of 5 squared is 5. That comes out. And here you have 4 squared minus 3 squared. 16 minus 9 is 7. So the answer is 75 times square root of 7. And that is one of the choices in that paper. Okay, I kind of rushed through that, but as I said, you will get the solutions in detail, but it's best for you now, and if you're a diligent student, you'll go back and do the ones that you couldn't get, right? Try it out again on your own, and you should be able to get it because we've just seen the solution. But if you can't, then just wait for the solutions to come to see where you went wrong. But in the end, you should be able to solve every one of these 20 problems, as I said in my preamble, right? That is what you have not been able to solve is more important than what you were able to solve.